Today in Centurion math, we'll be isolating a variable. Now, isolating a variable usually means to get the one letter that we use, our unknown, all by itself on one side of the equal sign. In this case, we've got x is equal to 7. Now, when we start to put things beside the x, for example, we have an x plus 3, and that equals, well, we can say that that equals 7 as well. We got to remember that we want x all by itself, so we want to get rid of the 3. In other words, whatever is with the x, we just want to get rid of it. We don't want it there anymore. So how we do that is we perform the opposite operation. In this case, we've got a plus 3 beside the x, or with the x, so what we have to do is we have to do the opposite operation, which is a subtract 3. So what we do on one side of the equal sign, in this case the minus 3, we also have to do that to the other side, and we subtract 3 from that side as well. So since we've got a plus 3 minus 3 on the one side, we end up with just simply an x. And on the right side, you can see that we've got the 7 minus 3 here, which we now know as 4. So you can see that we've isolated the x, we've put the x on one side all by itself, there's nothing else attached to it, so our answer is x is equal to 4. So in summary, we want to isolate the variable by eliminating operations using opposite operations to both sides. Now, this method works for a number of operations. For example, if we start with our x again, and instead of adding, what we want to do is we say, well, x divided by 3 is equal to, let's go back to 7, but we'll make it a negative 7 here. We got to remember that since we have a divide by 3 attached to the x, the way that we get rid of it, in a sense, is to multiply. The opposite operation of division is multiply. So we have a 3 times the x divided by 3. And again, we perform this operation to both sides of the equal sign. So we multiply the 3 by the right side, which is negative 7. We have our 3 divided by 3. We like to reduce these first to make the numbers smaller. So 3 goes into itself once in both cases. And so our final answer we have is x is equal to negative 21. One of the other concepts that we can introduce here is to check our work. And what we generally do here is we put our answer for x, in this case is negative 21, and we put it back into our original equation here. So on the left side, we have a negative 21 divided by 3. And what we're doing is we're hoping that that is going to work out to be whatever our right side is. In this case, it's as simple as a minus 7 or a negative 7. Well, 21 or negative 21 divided by 3 we know is negative 7. So since our left side equals our right side, we know that we got the right answer.